Thank you. So thank you. Welcome to this session straight after lunch. I hope you all enjoyed your delicious lunch and got some sunshine. I'm Kerry Levett. I'm the Solution Architect for the Thematic Research Data Commons. I'm presenting today for Hamish, Holewa, the Director, who can't be here. We have a number of speakers today, and then we'll have a panel session. So hopefully this will be quite an interactive session. And we've got questions, and we've got online participants as well. So I'd like to start by acknowledging the traditional owners, the Turrbal and Yagara peoples of the land we're meeting on, Meanjin or Brisbane, and I pay my respects to elders past and present. And I'd also like to pay my respects to the Kaurna people on whose lands I live and work in Adelaide. So welcome everyone, welcome to everybody here in person and our online attendees. So we're going to have lightning talks. If we've got time, you can ask them questions as soon as they've talked, but otherwise we can wait till the end when we have our panel discussion. So first thing, I'm just going to give you an overview about the Thematic Research Data Commons and about the Trusted Environmental Data and Information Supply Chain Program. So first, briefly about ARDC. You'll probably hear this a bit during this conference, but the ARDC is enabled by the Australian Government's National Collaborative Research Infrastructure Strategy, or NCRIS, and our mission is to accelerate research and innovation by driving excellence in the creation, analysis and retention of high-quality data assets. So researchers are at the centre of everything we do, including academic, government and industry researchers from any discipline using any technology. And we also work with people and organisations that build infrastructure and that support the researchers, and other key stakeholders, the Australian Government, research funders and national and international research data organisations, and our ARDC members. Just a little bit about what we do. ARDC runs the Nectar Research Cloud. I'm just going to go through these really briefly. The slides will be available at the end so you can have a look in more detail. We run national information infrastructure like Research Data Australia, and we have persistent identifier services. And we have a skills and workforce development that looks after our NDRI workforce, users of our Thematic Research Data Commons, ARDC services and tools, and we also run communities of practice. So talking about the Thematic Research Data Commons, what is a Research Data Commons? Well, it brings together people, skills, data and related resources like storage and compute and software to enable researchers to conduct their research. So we have 3 Thematic Research Data Commons at ARDC. People is for health and medical researchers, Planet is earth and environmental science research, and then we have the Humanities, Arts and Social Science and Indigenous Research Data Commons. So, as I said, Planet provides national scale data infrastructure for earth and science researchers, policymakers and decision makers. We bring together research, government and industry to develop systems and processes that make data more available and speed the development of analytics and decision support tools. And that QR code, you can find more information and get involved with the Planet RDC. I'll have that on at the end as well. So in the Thematic Research Data Commons, we have 4 focus areas. We have trusted environmental data and information supply chains, which this session will be focusing on. We have integrated fair data sets and services, where we enable national scale fair data sets. We have modelling, analytics and decision support infrastructure, so that's our platforms and platforms like EcoCommons and Biosecurity Commons. And we have a program related to governance of Indigenous data and skills. So what is a trusted data supply chain? It's talking about taking data from when it's collected until it's used. So going through collection, curation, integration, analysis and use, each process builds on the previous one. And these processes, just like a normal supply chain, these can be done by different parties. And it requires coordination and trust between those parties to work effectively. So, So currently with environmental data, some of the issues are lots of duplicated effort, different parties are doing the same thing. There's gaps in data collection. There's a lot of inconsistencies in standards, both for collecting data and for exchanging data. There's multiple bespoke technologies and a lack of transparency in integration and analysis. And there's a lack of use and reuse of existing evidence in decision making. So with the Trusted Environmental Data and Information Supply Chains, or TDISC program, we realise that research and decision making rely on this supply chain of data and information from multiple domains and disciplines. We recognise that industry are really large generators of data and information products, but this is not really easily shared. End users need to be able to trust the data and models that have been used to create decision support tools and products. And we need to develop infrastructure, incentives and policies to share data and models between research industry and government in a way that respects industry needs for security and commercial and confidence data and engenders trust. So these are the building blocks that enable trusted data and information supply chains. So to engender trust between stakeholders, we need governance that connects between the different stakeholders have their own governance setups and they need to be able to interoperate. We need to respect Indigenous cultural and intellectual property. So we need strong governance of Indigenous data. And we need to streamline data sharing agreements because most of you will know how hard and time-consuming it is to get bespoke data sharing agreements between organisations. We need fair data and software so that we have interoperability, we have known quality and known provenance of our data and software. So we need it to be fair. And we need the technology to move and use the data and models. So that's what the projects in the TDISC program are enabling. So we have 3 regional use cases in the TDISC program. Each use case is and project is piloting and developing technical infrastructure, governance frameworks, and trust mechanisms that allow regional stakeholders to collaborate to produce trusted data and information products for their regional use case that they all benefit from. These infrastructures are extensible and reusable and will be repeatable patterns for other regional use cases to follow. So in terrestrial, for the resources industry, we have the CEF, which Owen will be talking about, led by WAMSI and WAMSI. In freshwater management, we have the Guyanese Data Hub, and I'll be speaking about that. And for offshore renewable energy, we have the ORE TDISC, which Peter will be talking about. Okay, so that's it from me. I'll hand over now to Owen. So we'll have Owen first, and then we'll have Peter, and then Shada, our Director of Translational Research Data Challenges, is going to talk about the food security TRDC. So, Owen. You can use the
Thanks, Kerry. That seems to work. So as Kerry said, WABSI, the West Australian Biodiversity Science Institute, is working with our sister organisation WAMSI, the West Australian Marine Science Institute, on a programme of work that we call the Shared Environmental Analytics Facility. And importantly, facility in the banking sense, not the infrastructure sense. So enabling, not building a great big monolith. Building the enabling environment for shared environmental analytics. And we've linked up with our partners at ARDC in the Trusted Environmental Data Supply Chain to show that in practice. So working through from that industry point of view, from a regulator point of view, and demonstrating what it takes to get from an observation in the field to a useful product that is shared and reusable. A little bit about WOBSE. We're a state-funded entity. We're a joint venture of 10 organisations, 4 universities, 4 government departments, CSIRO, which is the national science organisation here in Australia, and the West Australian Museum. And we were established to really get into the heart of those issues that are cross-sectoral, challenging. It's an overused term, but the wicked problems, things where multiple stakeholders, multiple levers, very unpredictable and challenging outcomes. And one of our first challenges was data. Get after the data. And I don't need to tell anyone in this room why that's so important. Foundational to doing anything else is get after the data. So we've been working on that process, and we've got our acronyms. We need help with our acronyms. We've got SAFE, the Shared Environmental Analytics Facility. It's not a typo that this slide says SAFE, which is the Shared Analytic Framework for the Environment. Same letters, different order, different meaning. But this, you'll recognize up the left-hand side there, I've rotated the little diagram that Kerry had in her slide from the Samuel's review of the Environmental Protection Act. To show that collect, curate, all the way through to analyse and use, and really working with our partners across the environmental supply chain to say, where are you in this framework? What are you really good at? And who are you dependent on? And who are your dependents? Who's dependent on you? Who are your customers is how we sometimes phrase it in working with industry, but not always a successful way of phrasing things with academics. Who are your customers? So the SAFE framework builds this flow through to the top where you need to put that data to use. All the work, collecting, curating, caring for, loving, integrating those data sets, those are all costs. The benefits come when you start to put that data to work. So we really wanted to understand how we could put data to work in supporting better environmental outcomes, better economic outcomes for our state. And one of the things that is striking is how much of that data is held by private industry. So in Western Australia, around 90% of environmental data is generated and held by private industry, not the university sector, not NGOs, not government. 90% coming through private industry, held privately, held securely, off on their own spaces. So how do we get a shared facility that can actually access not just the publicly available data, but the private data too, which is where the bulk of data sits? So our users of the facility are across government, regulators, industry, the research community, regional communities, traditional owners are all target users of this integrated facility that enables access to and use of data. And again, reaching back to Kerry's slide where you've got those shared models, shared data sets, and then access to the private data, linking those things together to enable better outcomes in decision making. So that requires a number of enabling pieces of infrastructure. The platform, how do you share securely? The governance, how do you manage those agreements? And we've developed both a platform and a governance framework which sit in a hub and spoke space. So a cloud-based platform for integration of data where you can have different spokes in different regions. We've got 2 pilot regions, one in the Pilbara, one in Coburn Sound, which is a marine exemplar, port development. And then within each of those spokes, multiple zones where individual organizations can hold their private data, but models can access all of that information. So you get a shared product out at the end, so you understand what's happening in the region from the perspective of all of the data that's available. So we've got that layered notion, and the intent is therefore to make that scalable where you can implement another spoke. So we've just implemented another spoke in the Northern Territory. We're looking at implementing a spoke with the Northern Territory government to answer some of their challenges in a port development. So lifting the structure from Coburn and placing it on another port. So you get that efficiency as you move forwards. Same thing, different pictures. Data flowing from industry partners, data providers, so the publicly available or the commercially available data sets. You've got agreements within spokes around data sharing, and those are controlled real time. And this gives our industry partners confidence. So they can go into a partnership and they can dissolve that partnership. Their data hasn't been given across to somewhere where they no longer control it. So what that does is it translates science and knowledge and data into decisions. So it allows us to put the best science with the best data to make the best decisions. It's a really collaborative endeavour, as well as our partnership with ARDC. We're working with state and Commonwealth government, industry partners, and software and technology partners globally to deliver this pilot. Our aim is to make our work robust, repeatable, and sustainable in terms of environmental decision making. It has to be scalable to other regions. No point in building a fantastic whiz-bang system for one point on the planet. The challenges we have are ubiquitous. Has to be trusted, so there has to be that level of trust. So understanding the models and the science and that best science, the published science, the peer-reviewed work feeding in into that space. It needs to be secure, both for the private industry partners, but also for the government and regulators that are using it, because they're putting secure data in there as well. As an example of that, locations of threatened species are usually obfuscated. So there is a threatened species somewhere in this square kilometre. Not wildly helpful if you're planning where a road's going to go. So having the actual data point for where those plants and ecosystems are. And as we operationalize that delivery, it's using the best science, identifying the gaps, then reinvesting in new science, new data acquisition as we move through the system. So what does it look like in practice? In Coburn Sound, we've got an embayment that is near the capital city, Perth, and the state government has decided that rather than having the major import and export facility for the state in historic Fremantle, where it's completely surrounded by the city and all of the heavy goods vehicles have to go out through the city, they're going to move it to Coburn Sound and develop a new port. Sounds like a great plan, but developing a new port is a major infrastructure project, involves significant environmental change in a system that has seen change through a long period of time. On top of that, we have 2 desalination plants that are looking, or our water provider is looking to build 2 desalination plants in the same region. The naval infrastructure facility is being expanded for shipbuilding, and assuming nothing's changed since I came into the room this morning, we're still in AUKUS, and we are going to have a nuclear submarine base in Perth, as well as a nuclear submarine maintenance facility. So huge amounts of infrastructure development in a very small footprint. So understanding that the data that's collected in that is reliant on understanding the system. So the first step in Coburn was investment into a major science package. So developing the science to actually understand the system so you can start to build models and run those scenarios out into the future. All of that science put together into an integrated modeling platform on SAFE with the ability to then look at impacts of various activities, to look at, this is an exemplar here of a dredge plume for a hypothetical channel. It probably doesn't show up particularly well on the left, far side of the figure. There is a hypothetical channel being developed, and then over on the right you can see the sediment plumes that come from that. So being able to do that isn't new, but being able to do that with shared data is. Being able to do that and understand that other people's basis of design, which is still confidential to them, are in the model. You can't see it, but the model can. It's breakthrough. So the Westport development has changed some of their design to allow for impacts it would have on the desal plants, which they would never have known until they built it previously. So better outcomes for industry, better outcomes for the environment, and better outcomes for the community, where you can have a state of environment type report being run regularly for that region. So robust, repeatable, and sustainable. It's our buzzwords. The Pilbara, we often talk about the Pilbara region. It's an international audience, so Pilbara is somewhat larger than France. It's a small part of our state, but a very large space on the planet. So we've initially taken a sub-regional approach to try and understand groundwater in that region. Why groundwater? Well, because it's one thing, it's highly regulated, and you cannot understand what's happening to an aquifer if you only know what you're doing to the water. So if I'm pumping water into the aquifer and Rosie's pumping water out of the aquifer, and the traditional owners say, why has our spring stopped flowing? I can't tell them, Rosie can't tell them. So having a shared understanding of that is essential. We've built that shared groundwater model and now are extending into flora and fauna across the landscape. So a whole suite of modeling outcomes based on the shared data that then build across a landscape scale for species distributions and decision-making in a way that is enabling industry, protecting the environment, and having economic benefits. We've done economic analysis, and if we can take 3 months off a decision-making process that currently runs for 36 months, it has a $1.9 million a year net present benefit because of the size of these projects. So, sorry, not 1.9, 109. 1.9. 1.9 wouldn't be a particularly good return. $109 million a year on the projects. So we're pretty confident that we can extend out to other regions, and with that, I'll maybe hand over to Gippsland and Peter. Thanks. If you want more information, you can QR code.
We do have time. It's not working. We do have time for a question.
Yeah. If we need to, I can repeat the question.
With this, yes. Hi everyone, it's Eric Laurie from the Australian Institute of Marine Science.
Yep.
My question is around the incentives for industry to put into this commons. It seems like the key element here is that they can put the data into this shared pool, but it doesn't come out directly, only through modelling. What is their incentive to contribute to this? Is it that they're required, or is it that it benefits them?
So their incentive to do it is partially driven by the approvals process. So to get approval for a capital development, you need to go through an environmental impact assessment. To go through an environmental impact assessment, you need to be able to assess what is happening on a regional scale. And for any individual proponent or company, they only have data about their own activities, and so they'll make assumptions about everybody else's. So if you have 5 proponents working in the same system, and you've got 5 different sets of assumptions, and then the regulator has a 6th version of reality, decisions are slower, more difficult, everything has to be challenged and debated. So the incentive is you put all your information together to get an outcome, which is, because you would be modeling your outcome anyway, because you're trying to project what the impact of your project is going to be into the future. So if you can do that from a shared version of reality. Let's not say it is reality. It's a version of reality. But if we all work from one, then the debate is about the impact of your project, not the assumptions that you've made for your modeling. So that's the very simplest version of why people put their data in. They need to reduce risk.
Great. Thanks, Owen.
Yep.
Yep, one more.
Great presentation, thanks. My name's Will Francis from Geoscience Australia. I was just wondering about the modelling process. So with the company data being sensitive,
yep.
Who's the gatekeeper for what constitutes a model in CEIF?
So who's the gatekeeper as to what constitutes a model?
So what's to stop me creating a model that says data in equals data out and getting access to all of the raw data?
Okay, yeah. So that's a good question. And the models that are implemented on CEIF, so access to CEIF, it's not you can't just go and log in as a random. So access is controlled. Models that are put in there are mainly coming from the regulators. So these are the models that the regulator uses to make their decisions. That's how we are saying this is the best practice model. And the implementation of new models in the system would be implemented through agreement of the partners in that spoke. So it wouldn't just be a single actor going in. But yeah, having a backdoor in a model, I hadn't thought of that. I'm sure our tech people have. I'm not a tech person, but I'm sure there's been some deep thought on that to avoid that. But in principle, the models that are being implemented are regulator-approved models or peer-reviewed models that are going in, rather than bespoke models being created. Well, they can be created, but then reviewed before they're implemented. Yeah.
Thank you very much, Owen.
Excellent.
All right.
Thanks.
Now we have Peter Walsh from the Institute of Marine and Antarctic Studies at UTAS.
Hi everyone, and thanks for coming along today. I wanted to talk today about a new project. The ink has barely dried on the contract, and thanks Rosie, just before you leave, for signing. So we're looking at a very similar project, but we're quite a long way behind where Owen is at the moment, but looking at the offshore renewables sector. So just a little bit of background. This project is going to be led by us at IMAS. We're doing it in partnership with the NES Marine and Coastal Hub and ARDC, and working with a lot of other data providers as we go along, including Geoscience Australia, of course. I was heartened to see this diagram up there before. I think it shows that none of us are actually operating in silos, that we are communicating with each other, we are working together, and we're each playing to our own strengths in this group of projects, and even beyond this group of projects. So, background of the work, as Owen mentioned before, includes the EBC Act review and the Shared Analytics Framework for the Environment, or SAFE. These introduce supply chain concepts to improve delivery of data and information for managing the environment, which improves efficiency, automates tasks, removes duplication. It's a standards-based approach, maintains good provenance, which helps us establish trust, confidence, and ensure fit-for-purpose data, and has targeted end-user products to address specific use cases. And so we're moving from the left situation, where we have a lot of issues in that supply chain, to the system on the right, where we remove a lot of those roadblocks that exist in that supply chain. So from a technical perspective, we're doing this through things like fair and open data, but it does include managed access to data that can't necessarily be open, and we do it through good technical standards for elements like metadata and integration. So the benefits that come out of this, for researchers, it's improved and timely access to more data, improved ability to translate research into impactful outcomes, and I think that's actually a really important sentence. For government, it gives us faster and easier evidence-based decision-making through tools and products tailored to specific use cases. And for industry, it gives us secure data integration where it's needed through tools like CEIF. It delivers transparency through sharing data and models, and this also supports and improves social licence. So this is a quick example of a conceptual data and information supply chain, and I have every belief that as we move through this project, this diagram is going to become much more complex. But it looks at multiple data sources, taking through QA processes, and we've got a bit of, there's an arrow there that's gone a bit astray, I think, in copy and pasting between templates, but I think you'll get what I mean here. It aggregates through transforming and harmonising the data, and then fed it into a modelling process and delivered it as an information product. So a slightly more complex scenario could include many disparate data sources coming together to solve certain problems. Those disparate data sources requiring a lot of processing, multiple aggregated data products feeding into models, and multiple model outputs and data providing combined outputs for information and decision support. So the aims of this project as we moved into it can be summarised as establishing trusted standards-based environmental data and information supply chains. It'll use the Gippsland offshore wind zone as a use case to develop scalable, national, adaptable infrastructure. So we want to take what we do in Gippsland, develop it in a way that we can then scale that nationally. And we'll collaborate with one of the NEST projects that is doing a lot of working on modelling cumulative impact in offshore renewables, and we will work with those guys to make sure to help get the data in there and secure those pipelines so that we can do this on an ongoing basis. And we'll engage with all three sectors to co-develop standards and principles. So this will build on the success of other projects that we've seen here and overseas, including the UK Marine Data Exchange. And a bit of self-promotion. It'll also improve on CMAP Australia, which is a platform that we developed primarily around delivering information to end users as a decision support tool. So we've done that for marine parks as part of DQ, and we've also done some work on I want to say carbon sequestration, but it's not. It's carbon abatement. Used as a tool for, in this particular case, was used as a tool for selection of sites for the next Olympics to be able to. So I just wanted to throw this diagram in. This was just a mind map that we started to do at work literally last week. Just starting to map out all of the standards and protocols that we need to adhere to as part of this. This is looking at a lot that we do already use. We know that there's a lot that we need to add to this diagram. And I think it just conveys the complexity of everything that we need to keep in mind, because each one of these standards and protocols that are in here, if they're not implemented, can be a roadblock on their supply chain. And like any good supply chain, it's only going to be as strong as its weakest link. So it's really important that we map this really accurately and then apply that across the supply chain as needed. So looking at the current state of offshore wind practices and standards, we're in an evolving space. The research is moving quickly and focused on improving data collection in particular. We're keen to really move into that area. Data analysis and derived products for environmental assets. So the data collection process, if we look at it across aspects of the research world, there's some places where we do that really well. Bathymetry is a really good case example of one place that we do that really well. But there are other areas, quite often involving data on seabirds and mammals, we really need to get much better focus on how we collect data in really uniform ways and set up standard operating procedures to be able to do that. There's a lot of variability in current practices and standards. Variation in data standards and practices can affect our project implementation and outcomes. And there's quite a few emerging projects, and we need to make sure that they don't exist in silos and that we work together. A very quick one to just show, if you lean your head to the left, the number of data portals that are operating in this area. And in the diagram on the right, a number of areas of programs and projects that are working in this space. So again, highlighting the need for us to work together. In terms of ways forward, we have Australia's draft Sustainable Ocean Plan that will eventually come out. And we also have the National Marine Science Committee, who are working on the next National Marine Science Strategy, and particularly have a white paper on data through to information. I'm just about to get the Time's Up sign thrown at me, so I'm going to jump through this quickly. Ways forward, working with the different groups that are in there and taking ourselves into a very mature area through a series of processes. And that's it. Thank you.
Thank you, Peter. Now, do we have any questions? You could talk through your last slide more slowly if you would like. Is there no online questions? No? Oh, okay.
Hi. Hi, David Curry from the Marine Institute in Ireland. I'm just wondering what the relationship between the TDISC, the project you're talking about, and the second project, where it looked like there was already infrastructure in place to do most of this. Can you just use what's already been done and use that like a different hub for marine data? Or is there something different that needs to be done?
Yep, that's a really good question. So Owen's group has moved into this from a space and correct me if I'm wrong, Owen, but have moved into this from a space of originating their work where they're talking about the need to share industry data and the need to have secure mechanisms in place to do that, and so working with the industry quite early on. At IMAS, we come from a very open data background. We implemented the AODN model, so IMOS, the Integrated Marine Observing System, and they have their data management arm, which is the Australian Ocean Data Network, and they have a model or an architecture for their infrastructure, and we adopted that architecture. It's based very much on open data, so we can only work to currently a binary model of either open or closed. We don't want to lose what we've gained in the open world, so we want to learn from what Owen's group has done with CEIF and then apply that to that AODN model so that we build that on top of and around that model instead. So that's part of the story. The second part of the story is that it's a different use case. A really important part of, and ultimately the goal of what we're trying to do here, is deliver systems that provide transference of knowledge and decision support. And so it's really about research translation. And it's my belief, and of course I work in this area, so I'm biased, but it's my belief that as technologists, we have a very critical role to play over the next decades in research translation. And I think that's a really important part of it, so that we actually translate that research into real-world impact through decision support and transferring that knowledge to the people who need it. Hopefully that answered the question. Yeah.
Excellent, thanks. Any other questions? Okay.
All good.
There you go. Thanks, Peter. Okay, so I'm just going to talk about the third project in the TDISC program because the project lead, Professor Richard Kingsford from the Centre for Ecosystem Science at UNSW, couldn't make it, and so I'm going to present slides that have been given to me by Dr. Jose Ferrer-Paris, also of the centre, and who are the project leads. So the third project is the Guiene Data Hub. And yeah, Jose's very kindly provided me with these slides. So Guiene is 85,000 hectares of complex, dynamic and interconnected ecosystems in the Murrumbidgee catchment in southwest New South Wales. It's one of the largest wetland restoration projects in Australia, involving a range of non-government and government organisations. So the Ngari Ngari are the traditional owners of the Guiene country. The Ngari Ngari Tribal Council is an Aboriginal not-for-profit organisation that owns and manages Guiene, and they manage together with 3 consortium partners, the Centre for Ecosystem Science, the Nature Conservancy and the Murray-Darling Wetlands Working Group. Guiene represents a once-in-a-generation opportunity to create a new, sustainably managed and financed conservation property for the benefit of people and nature. Now, I'm hoping this is going to work. They've provided me with a fabulous video that I'm going to let play while I talk through some of the other slides. So, Guiene is, as I said, 85,000 hectares. It's a really large property. And what they're trying to do on the land is restore the ecosystems. It's wetlands and grazing lands. They want to enable the cultural connections to the land. They are the environmental water managers for this area. It's connected. The Murray-Darling is Australia's biggest largest river system. They also have youth health programs and Aboriginal rangers on the property. They're looking at sustainable economic options, renewable energy, seed collection and education, as well as grazing. And they have a permanent protection agreement of 55,000 hectares in perpetuity. So now, Guiene represents, they have what's called a healthy country plan, and Guiene represents an exciting new and unique model of management with traditional owners at the centre, driving adaptive management supported by evidence and informed by their knowledge, experience and those of their government and non-government partners. And they have a commitment to deliver effective long-term management to achieve a flourishing natural and cultural landscape focused on the 3 pillars of environment, culture and economics. I will just let this. All right. It's a pretty amazing country. So it hosts a lot of migratory birds. So they're actually looking at it for Ramsar wetland status. And yes, okay, I'll go to the next. Okay, I've talked through that. Oh, so that's just a map of the area. It's very large. Okay, so these are some of the partners. As I said, Ngari Ngari Tribal Council, Murray-Darling Wetlands Working Group and the Nature Conservancy and Centre for Ecosystem Science. And these other government and non-government organisations do research on the property, or they contribute data or use data from the property. So the Guyanese Data Hub project is looking at bringing in data from all of these different sources, having a consistent level of curation, being able to bring it together and analyse it for a number of different uses. So we've got research users who want to look at analyse environmental water flows and do research on sustainable grazing and all of the wonderful species that exist on Guyanese. Government stakeholders need to write state of environment reports. They need reports on the environmental flows, and the Biodiversity Conservation Trust is interested on the management, adaptive management, and how it's impacting the biodiversity. And the Ngari Tribal Council themselves, they need to write these reports, they need to manage the property, and they need to manage the people that come on and off their property. So there's very diverse uses, but they're all needing the same data. So that's what they're trying to enable. And this project has only just started. So thank you. So now we're going to have Shada Hedavi is our Director of Translational Research Data Challenges, and she's going to talk about some of the projects from this food security program and their industry connections.
Hi everyone. I want to start with acknowledging and celebrating the first Australians on whose traditional lands we meet, and I pay my respects to the elders past and present. So I'm going to talk about ARDC's Food Security Data Challenges program. It's part of our Translational Research Data Challenges initiative. So in the Translational Research Data Challenges initiative, we basically start with a societal problem. So we've done one in the past on bushfires, and the one that I'm talking about today is food security. So we start with a societal problem, and we look into what are the data challenges that are the barriers for further research in that space. And then we build digital infrastructure solutions to address those data challenges. So in this program, we basically have 10 different projects, and we cover a very wide area from agriculture, aquaculture, antimicrobial resistance, traceability and food provenance, nutrition, food equity, food relief, and animal disease outbreak. Given that there's a really wide range of topics in the food security, the projects go quite broad, so I'm just going to basically say that we have 10 different projects in this space. We will be putting links into the projects if you want to learn more about them. We recently did a forum, and there's little presentations about each of them coming up soon. But these projects basically share common data challenges as well. Like with the 3 that are marked here, they all used what we are working on as a data code, which is basically a data sharing agreement. How can they share data? A lot of the projects have challenges around sensitive data, and they're also helping each other in addressing those, and 2 of them also had the challenge of developing an ontology and common vocabularies. So I'm going to go deeper into 3 of the projects, just in terms of partnerships, to give you a sense of what are the sort of projects that are there. First one was building a traceability data infrastructure to track provenance and quality in Australian seafood supply chain. This was a partnership mainly between ARDC and one of the states, Queensland, because they were catching a lot of mud crabs there. So that's the reason behind the partnership between ARDC and the state agency there. The mud crabs have a very high market demand and price. And for that reason, there's a lot of illegal fishing and black market in that space. And there's a market of about $50 million per year in Australia for that. And each kilogram of mud crab is more than $100. So that creates a lot of illegal and black market there. So the aim was to improve traceability of the data platform and interoperability between different fishers who catch mud crabs to be able to trace the food. Their big motivation was compliance, to be able to understand the catch and also the effect that goes into those catches. And it was about mechanisms for provenance and quality tracking as well. So just showing that there is a crab trace in place now, and they did this project three work packages of, first of all, understanding the supply chain, where they're catching the fish, who are the providers of the data, so the data and metadata standards that are in that space, and building a digital data infrastructure. So this was a very quick overview of one of the 10 projects. The next one is a partnership between ARDC and Australian Bureau of Statistics. This one looks into more of a food equity lens. So the Australian Bureau of Statistics have access to the big supermarkets in Australia, and that's a very rich data set that obviously not everyone can have access to because of the sensitivity and the competitiveness of the data. So this is a project that is basically gathering data from the different supermarkets to provide an overview of what is the food that is being consumed at different regions in Australia. So the aim is to develop a method and a system for production of apparent consumptions, estimating for subnational or small geographics. For example, providing dietary quality indicators, on the remoteness, on the state and territories, and the main outputs are a dietary quality indicators for subnational geographies. For this one is 2024. So here I have one map. There is more data coming in the next few months because as they were developing the system, they realized how sensitivity is, even though we are going like SA2, still because there's only one supermarket in that region. That makes it very difficult to share the data in a non-sensitive way. So the data is coming up soon, and it's basically providing data as well as a dashboard to show consumption of, let's say, carbohydrates or fish at subnational level. And that was with Bureau of Statistics. So this is an example of a government partnership, while the previous one, even though it was with the government, it was mostly with industry because they were the little fish grabbers. The next example is a partnership between ARDC and Food Bank Australia, which are basically an NGO providing food relief to the organizations. And this is basically sort of a complementary project to the other one, where that one is looking into what food is being consumed, and in this one we were looking into what relief is being provided. So to define food insecurity, a person is food insecure when they lack regular access to enough safe and nutritious food for normal growth and development and an active and healthy life. This may be due to unavailability of food and or lack of resources to obtain food. So this project started in February 2022, and they were first only looking into basically providing a dashboard of the Food Bank Australia's data, but it was an internal project. Through ARDC's project that started in May 2023, we brought on board OzHarvest and Second Bite, which are basically the next two big food relief organizations and NGOs in Australia. So through this project, the three of them have started sharing data with each other and create a report on basically a sector dashboard to show where the food relief is going to. And they also have provided the First Nations map and the first food bank hunger map for the public that is going to be released soon. This is to just give a snapshot on, again, this is another sort of a dashboard, but this one, instead of looking into the consumption, is more looking into the food relief that is going into the communities. This is it. This was 3 of the projects, because I thought if I give overview of 10 different projects, it might become too overwhelming. But as I said, there's going to be links to all of the 10 projects, and they cover a wide area of partnerships and topics. Thank you.
Thank you, Shada. Has anyone got any questions? Hey. Okay, Stephanie.
Not so much a question, just a comment. If you're interested in hearing more about the food security program, we have a poster board 63, so you can come and see a bit more about the projects and the lessons learned from the program.
I was wondering what Stefan is going to ask me. She's the program manager of the program, so.
Do we have any specific questions? Okay, Thank you very much, Shada.
I think there was one.
Oh.
No, you're good.
Nope.
Okay.
Okay, so what we might do is get our three speakers to come down and sit down here, and I've got some questions for them. So what would like, yeah, so now feel free to ask anything, well, related to the topic, if preferable. I'm going to start off. So you've all had interactions with industry, and I'm curious as to, and this is sort of for Owen to start with, but how did you go about that initial engagement with industry and getting those partners to come on board? You talked a bit about their value proposition for them, but how do you actually go about that?
It's a long process, and I think we started out as WOBSE chasing data with the notion that it's environmental data, it's a public good, everything should be open, it's not commercial in confidence, it's environmental data, give it to us, just make it open, make it open, make it... and it's quite easy to convince the enviros within corporates, so the environment management teams, they go, yeah, it'd be great to have access to all the data, and if we all just shared it, it would be fantastic. It's even quite easy when you get into the C-suite, the CEOs, the COOs, the CIOs, all these titles. Yeah, they go, yeah, strategically that would look really good for us if we just did that. And then somewhere in between, you meet the lawyers. And invariably, they ask the question of, if we make this data publicly available, is there any risk in that data set? Could someone misinterpret it? Could we be exposing ourselves to criticism that we haven't managed or controlled yet? And the answer to that is, we don't know until we release it and combine all the data together and analyze it. And they go, kill this, shut it down now. So we had to pivot in our journey from being naively optimistic and idealistic and wanting open access to data, open data, shared data, to a narrative of access. So control and access, and you meet people where they are. The corporates understand the value of giving access to the data to make a better decision. They understand that eventually they might release that data once they understand it. And in fact, you know, at the moment, we're having a lot of conversations where we're saying, well, yes, that data is on a pathway to becoming public, but it will be 7 years old by the time you move through that process. And for environmental data, occurrence of threatened species, habitat, you know, clearing data, 7 years old is probably too old by the time it reaches the public. So having access early to make the decisions, and then it flows through and eventually comes out. So it was, for us, something of a journey to go from a point of wanting a common public good, environmental data. Who doesn't want environmental data to be shared? Who does it belong to? It's the environment. There's a tree out there. That's not my information. You know, it's just there. But when you actually get down to it, it really is about managing that access, understanding also where they're coming from. So we had a question from GA earlier. We use GA all the time with our minerals partners, our mining industry, because they do really commercially sensitive stuff like finding out where the minerals are, and they hand it over to GA to integrate with everybody else's data, make products, geological maps, which then have controls about how they're used. So they understand the notion of securely sharing data that is really core to their business. So if you can give them the security, they'll share the environmental data, which is core to getting their approvals, but not core to their business.
Has anyone got any questions?
Yes, please do.
I feel like we also have to, at least from ARDC side, what we are trying to do is convince industry why it can be mutually advantageous if they share their data. So it's about defining that shared objective and shared value sometimes. And I agree with Owen that it takes time to have those conversations on what we are trying to achieve. And something that we try to also advocate is, I understand they don't want to take risk, and we also have to respect their competitive value that they have with their data. It's about not everything needs to become open sometimes. It's about at least making the data fair, making the data findable, have proper catalogs in place, have proper governance in place so that researchers know this data exists, how can they find that, and what is the mechanisms to be able to ask for that data. And to also show industry what value the researchers can bring to them if they share their data openly, or more openly.
Thanks. Yeah, clear value proposition is really important in this space. So we just talked about it's important to have really good, clear governance. And you all mentioned that. I was going to ask Peter, you were saying that you're coming at this from a space that has done open data and data sharing really well, and now you're moving to work with some industry partners as well. I know you're looking at the data spaces model. Do you want to just, we didn't really talk about that in the talks, but do you want to say something about that?
Yep. So for people who haven't heard about the data spaces model, it's a model that encompasses various things. It has a strong focus on governance, on data governance. So how do we have sharing agreements and how do we structure those? And I don't know a lot about this space yet. I'm still learning. But it also has a series of standards that apply to the technical space as well, so that you can have interoperability between different data portals or different information portals or different modelling platforms that allow you to share the data very securely under a series of predefined sharing agreements. The thing that I really like about that model is because we've been through a couple of processes in other projects where we've wanted access to data and getting access to that data, and our experience mainly with this has been through fisheries. But getting access to the data has been a long, protracted process of coming up with some form of sharing agreement that allows us to use the data for certain uses, works against a place of distrust because we tend to work in a very open area, industry doesn't, and it's easy for us to have to go through a 12 to 18 month process just to get to access to the data one time. And that's something we really want to avoid because that's a lot of effort to go to. And then if you have to repeat the process, it might be easier next time and it might not. And we've had both of those experiences. Data spaces gives us a way of doing that negotiating up front, getting the data sharing agreement set up, getting the infrastructure in place where we can get access to the data relatively easily. It maintains a level of data sovereignty for the owner, importantly. So when industry hand over their data, they have control over who can actually access the data via those agreements, and they have that understanding of those agreements that is well defined to so that they can trust the people they're giving it to. And it then broadens across, as Owen was saying, it then broadens our whole data landscape so that we're working with a much bigger data set, but we're working importantly with a common data set and coming up with results that at least aren't polarised. We may not necessarily come up with exactly the same results between industry and research, but they'll be close and we can trust those results. Does that make sense?
I'll also comment briefly on data spaces. We're looking at an alignment and looking at the data spaces governance framework and the security protocols that we have in place. Our thinking at this point is that we'll be able to certify the SEAF platform as data space by default. So if you do everything that is secure for a CEF instantiation, a spoke, you then actually surpass what's required to be a data space, and therefore we can link in, and that creates opportunity for sharing that goes beyond the very secure CEF platform.
Yeah, so actually that's an example of the network governance that I mentioned as being important. So once, so if you have different data spaces set up, their governance will actually be interoperable between them. So it makes it possible, if it makes sense for the use cases, it's possible to network them. So ARDC's got a data spaces program at the moment. We're looking at data spaces as a European model. It's part of the European data strategy. It's where at the moment we're looking at its applicability in Australia. So CEF is one of the pilot projects, and mapping between the IDSA, International Data Spaces Association rulebook, and the CEF governance. So we've got a couple of pilot projects, one in biosecurity and with Plant Health Australia, and there's a data spaces test bed service being set up by RMIT, so people can test the technical components before they implement them. So is there any other questions? Yes, excellent.
Thank you, Manu Soding from Helmholtz Association in Germany. Since you were mentioning data sovereignty, I was just interested in, so we're also wrapping our hand about how to gain sovereignty about our data in our association. And so I assume if you're doing industry projects together with research, you're coming from both ends of sovereignty, like the industry taking full responsibility and closing their data versus the open research projects where we do try to open all of our data up. But in the end, we have to make a decision there. How open do we want to be, and how close do we want to be, assessing the risks that you mentioned that may come up that we do not have an idea about yet. So is there anything that we can learn from industry about data sovereignty that we may apply in research, in public research? Or do you say, well, we should still go open? I mean, what is the? I have no idea, no answer to that. I don't know if you come across anything that would shed some light on that for us.
I'll go first. I think there is no single answer to that, and open when you can, as secure as needed. Is really where we come from. We're drawing into the CEF platform to model from, from IMOS, from the global circulation models. If I think about the Coburn Sound example, less so in the Pilbara where it's mostly private data. So you've got open data that comes in and then gets combined with a secure data set. So the combined data set has to be secure, because otherwise you've violated your agreement with your provider, but an open product at the end. So we're a publicly funded entity. We exist to try and provide public good, and so we're always driving to that. Let's make the products of these analyses open, even if we can't make all the data open. So there's that ability then to go back and have access to rerun models, to challenge things, to do that. So open when possible and as secure as necessary.
I was going to say that we tend to look at open data and closed data as a binary model, and we need to look at it much more as a spectrum. And I think one thing we can learn from industry, we know that not all of their data is closed or tightly held. You just have to look at their annual report to see that they open up some data when they either want to or have to. So as you move through that spectrum of taking data that they're very sensitive about through a series of processing steps. At some point you reach a point where it becomes a stage where everyone is happy for it to be open. And that's the point. And if you come back the other way, you're moving from transparency through to a lot of opaqueness. And there's a sweet spot there in the middle that says we're being as transparent as we can about this. And that's important because it gives those companies a lot of social license through that transparency. So that's a really important aspect of what they're doing. But it remains opaque enough that they're not sharing things that they don't want to share, or in some cases can't share. I mean, we have the ASIC, the Australian Securities and Investment Corporation, who have certain rules about what can and can't be shared openly between companies. So there are even some regulatory reasons about why we can't actually share the data. But it's important that we set a spectrum of moving from closed to open and from opaque to transparent.
First, wanted to start by acknowledging that is a big challenge, and not only with the data, but also with even modeling tools, that if you make those available beyond to the experts, it can be used not in the way that it was intended for. And I think the same goes even in society with like AI and all the rest of the things that can be available and be used for the right purpose or not. And I think I agree with Peter that you just have to try to find the right balance there. But there would be times that that they can be used not in the proper way, but still hoping that the research and the benefit that you will gain is more than the risk that you're taking there.
Hello, I'm James Ayler from the National Oceanography Centre in the UK. You've also said, we'll pull the data in, or we'll get the data in. From my experience, have you had problems with that? Because it could be unstructured or not as well structured. Has that been a problem that you've easily overcome, or by starting at the front or working your way through it? Do you have any advice or yeah?
There's a lot of work in bringing together data that's come from different sources. We have done some work on some data standards for environmental data that is submitted along with an environmental impact assessment. So we helped the regulators with writing data standards. They're pretty low bar. So at least the data that's being collected by industry now is meeting that standard. But there's always work to be done. It's one of the things that building within the platform and the pipelines is automation of some of that data processing. So at this stage, there's a bit of manual churn as a new partner comes on board on alignment. And then once it's automated, we can pipeline their data into the combined data set each time it's used. But there is no silver bullet. If something as simple as different companies have different, so I mentioned groundwater before, you would think that the depth to groundwater from the top of a monitoring bore would be a really simple question. But some companies measure it from the color of the bore. Some measure it from the original ground level. Some measure it from a digital version of the original ground level, and some companies have changed over time but not actually made that clear in their data set. Yeah, so something as simple as that. How far down this pipe is the water? It should be a simple measure, but there's still some work that needs to be done on what contractor collected it on what date for which company, and then you can adjust it. It's an easy adjustment once you know, but it's churn.
I was going to say there's some great examples around and I apologise in advance that I'm really only aware of the Australian examples, but I'm aware of the work that Medin is doing, for instance, in the UK is really good. But we work a lot with standard operating procedures around our data collection. IMOS, the Integrated Marine Observing System here in Australia, have some great standard operating procedures for their data collection. Geoscience Australia, I know I keep saying, but it has got to be one of the best standard operating procedures that we've seen in terms of data collection, and so that we get this really nice uniform data that comes in. We're a bit nervous about our discussions that are going to be coming up with industry about their collection of data to contribute to bathymetry, because we suspect they haven't followed that standard operating procedure. But that's the kind of process we need to go through. And then there are some other examples that have come up strongly through citizen science or individual, for us, marine biologists working in particular areas. So seabirds is one. No judgment, because all of these people have gone out with the right objective in mind, but they've all collected their data in slightly different ways. They format it differently, and that's that diagram that I mentioned about the workflow. And we've started to unravel the seabird story a little bit, and that diagram is going to become much more complex. So, but I think it's about encouraging people to standardise those methodologies, publish them as standard operating procedures, and to go from there. And we as technologists, I'm more of a technologist in this space, we can look after the standards in terms of the infrastructure. We need the research community to step up, and industry as well, to step up and work together to create those standard operating procedures and those standards in that space as well.
I wanted to add that I acknowledge the challenge, and also I think part of the challenge is that it's different per area of research, and like among the food security projects, we had a similar challenge in different spaces. We had this in our isotopes project, which was looking into the isotopes data for food provenance. And then we had a similar challenge, but in our smart farms, we are looking into combining data that is coming from the soil, then the temperature and rain, then the plant growth, and bringing all of those data that can be captured, as you mentioned, in different ways, but also from different sources together. And that project looked into standardizing the data. And I think the challenge is every time you face a new sort of bringing of the data together, you sometimes have to redo this standardization.
I just put this slide up because I think that QR code should take you to the Thematic Research Data Commons page, and somewhere on there you'll find a link to the safeguard that both Owen and Peter mentioned, which is the shared analytic framework for the environment. And that's actually something that WOBSE put together and WOMSE put together to actually guide the conversation to getting these shared standards and operating procedures and metadata standards and provenance and persistent identifiers, all of those things we know we need to get data that's well described so that we can understand it and trust it. Right from the start, right from starting with having a culture of fair data and software. And so you put that together as a common language so that when you talk to industry and you talk to government and you talk to research, everybody was speaking the same language, because before that, we weren't even, just using those words didn't even make sense. So.
I might just throw in one more aspect to that, is that there's an element of that about the data that is fit for purpose. And you can quite often get a piece of data. So, for instance, if you're looking at a species distribution model, and forgive me because I'm not a biologist, I'm not a biometrist, I am a technologist, but if you're looking at a species distribution model, you're really interested in primarily species presence and potentially species presence absence. And so you can derive that data from many different data sets that are using very many different methodologies. So it's much easier to get data that's fit for purpose for a species distribution model versus something else where where if you're trying to come up with a marine habitat map, then the data becomes much more critical in terms of the consistency of the methodology that's been used to get to it. So understanding the use case and whether the data is fit for purpose also comes into question in there.
Okay, probably got time for one more question, if we have one. Okay, has anyone got any final things that they want to?
I think it's really important to say that we're on a journey of discovery, and the last thing we want to do is reinvent the wheel. So if you look at any of the things that we're doing and you go, oh, you've missed this, please don't be shy. Tell us what we've missed. Tell us we've got a widget that fixes that. What we've done is put some effort into bringing together things that we saw as best practice. So we've touched on using geological data as an exemplar with our partners. We've taken things from the health arena. We've taken things from security and defense in terms of encryption to be able to do things. We're a biological science institute, not an IT provider. And I think that's a really important part of we're collaborating across these ARDC projects with partners in different spaces, trying different things, bringing the best available technologies and approaches and governance structures to play to try and solve a common problem, not to be right. We're not here to be right. We're here to get an outcome.
Thanks. I think that's a really good ending. Thanks, Owen. Thanks for the closing. I'd like to thank all of our speakers today, and hope you have a good IDW. Please come and see us at the ARDC booth, especially if you want to talk more about Planet.